How to calculate gas properties using compressibility factor, Z. Imagine trying to predict how a gas will behave under different conditions. It's like having a secret code that helps you understand gases more accurately. That secret code is called the compressibility factor, or Z. When gases are at high pressure or low temperature, they don't follow the simple rules of ideal gases. Instead, they deviate, and Z helps us account for that. First, let's understand what Z actually is. It's the ratio of the actual volume of a gas to the volume it would have if it behaved as an ideal gas at the same temperature and pressure. Mathematically, it's written as Z equals the pressure times the volume divided by the number of moles times the universal gas constant times the temperature. For an ideal gas, Z is always 1. But real gases can have Z greater than 1 or less than 1, depending on how they deviate from ideal behavior. To find Z, you need to measure or know the pressure, volume, temperature, and amount of gas in moles. Then, plug these into the formula. Z equals P times V divided by N times R times T. You can also use charts or correlations that relate Z to reduced pressure and reduced temperature. Reduced pressure is the actual pressure divided by the critical pressure of the gas, and reduced temperature is the actual temperature divided by the critical temperature. These critical properties are specific to each gas and are usually available in reference tables. Once you have the reduced pressure and temperature, you can look up Z on a generalized compressibility chart or use a correlation. These tools give you a quick way to find Z without doing complex calculations. When you have Z, you can adjust the ideal gas law to better match real gas behavior. Instead of PV equals nRT, it becomes PV equals Z times nRT. This correction allows you to find the actual volume of the gas at your conditions by rearranging the formula to V equals Z times nRT divided by P. You can also find the density of the gas by using the formula density equals pressure times molar mass divided by Z times R times T. This helps in calculating how much space the gas takes up or how dense it is under specific conditions. Other properties like the formation volume factor or viscosity can also be adjusted using Z for more precise calculations. In practical terms, start by gathering your pressure, temperature, and gas composition data. Find the critical properties for your gas or mixture. Calculate the reduced pressure and temperature, then use a chart or correlation to find Z. Finally, apply Z in your equations to get accurate values for volume, density, or other properties. This approach makes it easier to predict how gases will behave in real-world systems, especially when they are under high pressure or near phase changes. Using the compressibility factor helps you make more reliable calculations and better understand the behavior of gases in thermodynamic systems and cycles.